Welcome back to the installation part of our course. In this part, we're going to take you through a complete installation project that uses a wide range of broadband RF applications. We'll take you through the planning, the installation, testing, and configuration steps. Now, our project is here on the outskirts of Tucson, Arizona, in this two-story split level, 5,600 square foot home carved out of the hillside. Now, all of the custom electronics are being installed by automation specialists. Let's go meet the owner, Dave Niddle.
Hey Paul, can you move those low voltage wires away from the high voltage wires up there?
Good morning, Dave.
Hey, good morning, Grayson. How are you?
How are you?
Good, thanks.
Good to see you again.
Thank you.
Now, we worked with Dave, an automation specialist, in the past, but Dave, why don't you tell us a little bit about your company?
Sure. We've been in business since '95. We do home entertainment, which is distributed audio, distributed video, and home theaters. We also do lighting automation, integration, security, and structural wiring systems.
Well, it sounds like a complete service custom installation company.
It is. We're one point of contact for the homeowner and for the builder as well.
Now, is Tucson still your territory?
It is. Tucson and some work down south.
Well, this looked like a beautiful project here. Can you describe the job a little bit for us?
Sure can. The home's about 5,600 square feet, and we're doing distributed audio with a nice little keypad control system for that, distributed video,
Nice.
home theater, lighting automation, security, and a structured wiring system.
Ooh, I'm anxious to see what you're installing. Show me around.
Great. We'll start here on the first floor. We'll go to the structured wiring panel in the utility room.
All right.
Thanks.
This is your utility room.
Yeah, Grayson, this is our Gray Fox structured wiring center.
Nice.
All our external sources will come in here. All our off-air, our satellite, and our broadband distribution will be located in here.
As well as broadband, you're going to use RF broadband. You're going to have broadband data network as well, right?
Right. All the ports in the house will have a broadband source, and all the computers will be connected on a network.
And the gateway and router switch you're going to put in here as well?
All that equipment will be located in here. Yeah. Additionally, we'll bring the voice lines from the outside utility and have a voice distribution module in here.
Sure. So you got voice, data, broadband, RF, all in the same box.
That's right.
Now, as well as external sources, I assume you've got a number of internal AV sources you're going to modulate.
We do. We have two of those. We have audio video sources coming from the family room entertainment center, as well as cameras around the house, so it'll be sent through the RF distribution module here in the enclosure.
Good. Now, what's this guy down here?
This is an enclosure that will house a security panel. It'll be a nice, clean, flush installation of the security system.
Yeah. Well, it looks very centrally located in the house where you got it.
It is a nice central location. We had one obstacle here with the HVAC mechanical
Ooh, yeah.
above, but we're going to come out around and across the top and run the wires straight in from the top. It won't be a problem.
Yeah, it doesn't look too bad. Now, you mentioned this entertainment center. Tell us a little more about that.
Right. The entertainment center is going to hold all the audio video equipment as well as the modulators, and the modulators are going to feed back into this RF distribution module and then feed the TVs throughout the house.
Let's go take a look at this. So this is the family room.
Yeah, Grayson, this
Nice.
is the entertainment center here in the family room. Here in the center, we're going to have a high definition television. Over to the left here, we're going to have our whole house audio and video distribution equipment and some sources here such as a VCR satellite for that distribution system.
Okay.
And then over on the left will be home theater equipment for this room. It'll be an audio video receiver, DVD, VCR, and a satellite receiver.
So you've got it separated out by whole house distribution over here, and most of this equipment is for local entertainment here.
That's exactly right.
Now, which of these sources are you going to modulate for whole house distribution?
We're going to use Channel Plus modulators and modulate 3 satellites, 2 VCRs, and a DVD. That'll go back through the Gray Fox structure wiring center and then distribute it out to all the televisions.
So you're going to put your modulators here and then route the modulated signals back to the distribution center.
That's right.
Well, that sounds like a pretty good plan. Now, I assume there's a speaker placement in here as well.
Yeah, we're installing a 6.1 system. There'll be a left, a center, and a right speaker, a subwoofer in the corner, and then 3 surrounds here in the back.
Nice, very nice installation. But I understand that not only is there not any broadband access out here, there's no cable service as well.
That's right. We're going to rely on satellite to bring in our entertainment as well as our broadband internet needs, and then rely on dial-up as a backup for the internet service.
Okay.
And for the off-air, we're going to rely on off-air for our local broadcasts as well as our digital television signals.
Oh, good. There may be some DTV signals you can pick up. That's great. You got the HDTV.
Correct.
Look nice.
Correct.
But driving up here off-air looks like it's going to be a major challenge in this area.
It's going to be a real challenge. Why don't I show you the situation up on the roof?
All right, lead the way. Wow, I see what you mean.
Yeah, it's a tough site. Broadcast from all different directions out here. So we have broadcasts coming from Tucson area, and we have broadcasts coming from the Phoenix area up here. From Phoenix, the DTV transmissions are coming, and we want to make sure we receive that here at this location.
Sure, there are live stations up there, right?
There are a lot of live stations up there. So we went to the CEA website and determined relative signal strengths and compass headings for this location.
Well, Dave, what can you tell me about the different stations you're going to try to pick up at this location?
Well, the Phoenix stations are coming out at 310 degrees over this mountain.
Woo.
The Tucson stations will be coming off the Catalina Mountains at about 81 degrees. The Santa Rita's about 124 degrees, and then off the Tucson Mountains about 255 degrees.
Wow. This is going to be a tough situation. Looks like your biggest problem is going to be multipath with all these mountains and trying to receive Phoenix stations right through this mountain?
Yes, yes. We're going to depend upon refraction to have the signal come down here and receive it off a highly directional, high-gain UHF, VHF antenna.
Wow. And since you've got so many stations spread out, you're not going to be able to use separate VHF and UHF antennas, so I assume you're going to rotate it.
We are. We're going to use an infrared-controlled rotator. And by the way, I've got a great spot picked here on the roof, and I'll show it to you.
Well, I was going to ask you, where are you going to put the thing?
Well, Grayson, I've chosen a place to put the antenna right here on this parapet wall here. It'll be a sidewall mount. It'll be located at a height where it won't be easily seen from the ground.
Well, it doesn't look like you've got many obstructions up here, so that ought to work.
It'll be clean.
Now, you're also going to mount your satellite dishes up here as well.
Correct. We have two dishes being installed, a multi-LMB DirecTV dish and a two-way broadband direct-way dish. Both those dishes will point southerly right over top of the house here.
Right. It looks like a clear shot to just to the southeast, isn't it?
It'll be no problem.
Now, it looks like your guys have already started pulling up the cable.
They've pulled up 7 coax, 4 coax for the DirecTV multi-LMB dish, 1 coax for the two-way broadband dish, another coax for the UHF VHF antenna, and then a control wire for the IR rotator.
Rotator, yeah.
Additionally, when we stub out through the roof, we put it through a conduit and turn it down 180 degrees to keep water from backfeeding into the house, and then put a roof jacket on it to seal it so no moisture can leak in around the pipe.
Yeah, looks like a nice job. Well, that takes care of the roof. Let's look at the rest of the house.
Right. Grayson, before we go on, I want to tell you about the cameras that are installed here at the house. We're going to have a camera here at the front door that's actually going to be aimed over the driveway and the garage.
Nice.
Another camera that's going to be aimed down here at the front door. A third camera downstairs at the rear rec room door. And then a couple cameras inside so the homeowners have some video surveillance while they're away.
That's nice. Now, I assume each of these cameras is going to be modulated onto their own TV channel?
Yes, they will.
And pumped through the in-house distribution system?
That's right.
Sure.
Look, Grayson, we're walking into the living room right now.
Oh, nice.
Yeah, these Southwestern custom homes present a challenge in the pre-wire. If you look up in the ceiling, there's not a whole lot of room above the Viga beams and then below the roof line for us to run our wires.
Yeah, tight, but it looks like you've done the entire pre-wire for the house in this small space up here from the distribution center throughout the home. Is that right?
Yeah, it was a challenge. Why don't I take you in the master bedroom? I'll show you what we've done in there.
Okay.
Here in the master bedroom, we have a keypad on the wall for the audio-video control here in the room, a pair of speakers in the ceiling, and then a voice drop over here at the headboard wall. And typical of a home, we'll actually drop a structured wiring cable behind TVs and computers.
Now, by structured wiring cable, you mean this 2 Cat5 and 2 RG6, right?
Yeah. Yeah, we use a wire from CommScope called UltraHome. It's got the dual category 5 and dual coax wires in it.
Nice. And this is pretty convenient stuff, I assume.
It's great for pre-wiring because it rolls right off the rolls during that process.
Tell us about the rest of the wire you're using for the job.
Up here in the ceiling, we're actually using a CommScope Siamese, what they call Audio Cat. It's a category 5 wire as well as a speaker level wire.
So you're running that from the to the keypads and
Right.
then regular speaker wire up to the speakers. It's
Exactly.
real convenient.
Exactly. Also up here, we're using just a straight Cat5e wire for any voice drop or network drop.
Yeah.
And in this system with the video distribution, we're running an RG6 to each TV.
Quad RG6 throughout the house.
Correct.
Yeah. So this pre-wire is pretty typical for most of the rooms. You've got broadband RF and data, speaker wiring, and so forth, right?
That's right. That's exactly right.
I assume that's the master bath, and you're putting audio distribution in there as well.
It is the bath, audio keypad, and a phone in there.
Good.
And why don't I take you down the steps to the office and I'll show you what we're doing there.
Okay. This landing is the office?
Yeah, this is the office, Grayson.
Nice.
And here we have a couple extra structure wiring drops, one on each side of the room.
Yeah.
And we've got another coax here for additional future broadband needs.
Good, in case we've got high-speed computer access we need here or something.
Exactly.
Yeah.
Now, why don't I take you down to the rec room and show you what we're doing down there.
Okay.
Well, Grayson, this is our recreation room down here. We're doing a pre-wire for a 6.1 surround sound system with a two-piece projection system.
Nice. Now, two-piece meaning?
Two-piece meaning we have a projector that'll hang from the ceiling up here.
Okay.
And at the front of the room, there'll be a screen that'll actually drop out of the ceiling when it's in use.
Oh, sure, yeah. And speakers are going to be up here as well?
Speakers will actually go in ceiling. It'll be 3 across the front, three in the back.
Nice. Now, what's with all the cable?
The cable is actually to feed video to the projector. If we have a video scaler driving the projector, we'll need 5 wires and what we're going to distribute RGB. If there's not a scaler, you'll use 3 for component, 2 for S-video, and 1 for composite.
So you got enough to cover every situation.
Exactly.
So these cables come from where now?
These cables come from a closet over here.
Oh, the one we saw coming down. Okay.
Yeah. We remoted the equipment into this closet because there's not enough room up front. So we have the audio video receiver, DVD player, VCR, and satellite in here to drive the projector. Now we also are bringing audio and video from the family room entertainment center down to here so that when the homeowner's entertaining, they can have the same video going down here as they are upstairs.
Nice. Well, it looks like your crew was getting an early start, so why don't we go give them a hand?
That'd be great.
All right. We're back at the house after 12 weeks for the next phase of the project. We'll be installing the structured cabling system, outlets, and testing the system, the off-air and satellite antennas, the cameras, and Dave and his crew are going to be installing the custom lighting and music distribution system. Your workbook has diagrams showing the interconnection of the major components of the RF distribution system, with gain and loss calculations, and the entertainment equipment that connects to the system. Good morning, Dave, Jim.
Good morning, Grayson.
Welcome back, Grayson.
Well, it looks like most of the house is done anyway.
Well, we're getting there. We've done our pre-wire at this point. We're back now to do our security trim out, our audio video trim out our wall plates, our tech ports, and then trim out our structure wiring panel.
Well, good. And I think we're going to do all the off-air and satellite antennas either today or tomorrow.
That's correct.
The wind dies down anyway. Now, here in the main entertainment center, all this gear and the other entertainment areas, you're going to wait to put in until after the homeowners move in, right?
That's correct, yes.
Okay. Well, I'm going to go take a look at the structured cabling panel, see what the progress is.
Okay, and I'll catch up with you later.
All right.
All right. So, Jim, this is a master control panel.
As part of the trim out, Jim and the crew are installing both external and internal coax jacks at each outlet using Gray Fox's self-terminating connectors. They standardized on gold connectors for external service and the nickel-plated connectors for internal. They're also installing an additional coax jack for possible satellite or future cable service at each outlet location as well. Once the outlets are trimmed and connectors installed on each cable at the distribution center, Jim performs standard TP and coax testing, checking for correct connector application and any shorts, opens, or incorrect labeling. Hi Jim, how's it going?
Pretty good, Grayson. I've got most of my cables terminated here and labeled, and I'm just about done testing them.
Wow, well we've made a lot of progress on this thing since I saw it this morning.
Yeah, it's come a long way.
Do good work.
Thank you.
Now, I assume that all of the voice and data modules are going to go in here and the coax distribution module on top, right?
That's correct.
And you got a lot of nice room here in this utility extra space down here. What are we going to use that for?
Right, we're going to use that for any cable DSL modem equipment or direct PC. It has its own electrical outlet just in case they need power.
Well, it looks like you're ready to start putting in modules.
That's right.
I'll give you a hand.
Okay, good.
Now, we're going to be using Gray Fox's 16-port coax distribution amplifier. This thing has 16 internal inputs, 16 external outputs, and all of the connectors you see with the little blue insert are self-terminating. The 75 ohm terminating resistor is removed when you insert a cable. Now this is the off-air or cable input connector, and it has a connector input as well for our camera inputs, which are combined in the camera module and come in here. It also has two inputs for a dual LNB satellite dish, and these are diplexed with the cable or off-air signal to these two external outputs you see here. We're not going to be using those for this job. It also has an adjustable gain control to adjust for a wide range of source input signal level. Okay, let's start with this guy. Now, I made up, we got a little short cable here to go for the camera module. It makes it a lot easier.
Right, it's easier to do down here.
Yeah. And this is our low-pass filter for the off-air antenna. This blocks things above channel 53, so in-house modulators, that's where those will go.
Okay.
Okay, that's tricky. Once the coax distribution module is in, we snap in the telephone distribution module, followed by the home office TP expansion module. Next comes the data router module with built-in switch, followed by a 4-port expansion hub. Next, we install the power supply and the power distribution module. Then Jim installs the camera module. This supplies 12-volt DC power over the coax to each camera, as well as combining their signals into one output. So that should be all the modules, right?
That's right. They're all
So the
in
last step is just get all the cables connected.
Right.
Okay, I'll check back with you in a little while and see how you're doing.
Okay.
Good luck.
Thank you.
Got a lot of cables.
Yeah, there's a lot of them here.
Jim starts by connecting the camera cables to the camera module. Then the power jumper cables to each powered module. He then installs the internal coax cables to the coax distribution module, followed by all of the external cables. Now once the coax cables are out of the way, he installs the TP data cables to the router switch, followed by the voice TP cables. And we can test for reasonable signal levels at each external jack by using my homemade signal generator. Now, I had to build this myself because you just can't find a piece of test equipment that does this anywhere at any reasonable cost. It consists of a video test signal generator that outputs various test patterns connected to the input of a Channel Plus frequency agile modulator. The output of the modulator is connected to a 0 to 22 dB variable attenuator. If you want to know how to build one of these, drop me an email. It's a very handy piece of test equipment. I'm going to first test the off-air source distribution, then the internal signal distribution to see if everything is working properly. I'll then check the results with the system gain and loss calculations Automation Specialist did in the planning stage to see if we're close. Now to test the off-air signal distribution, I'm going to connect the output of the signal generator to the antenna input of the distribution amplifier through the low-pass filter. Now I'm going to test it at channel 14 and channel 50. So I'm going to first set the modulator to 14. And I'm going to set the output to about plus 5 dBmV to simulate a good off-air antenna signal. I start by testing the signal at the external jack of a nearby outlet using our signal level meter set for off-air channel 14. I check for a reasonable signal level given the loss in the coax, then I check for a good carrier to noise level, then to make sure my hum level is less than 3%, and record the results. I'll later use this record to see what the maximum difference is between all the outlets. I then set the modulator output to channel 50 and recheck each outlet to make sure the system is operating just as well at the high end of the off-air spectrum. Now, based on our test results, we may have to adjust the amplifier gain or insert inline attenuators on some of the external cable runs to balance the signal levels out throughout the system. Now, if we do have to install attenuators, we're going to do it here between the external cable run and the external output in the distribution panel. Now, whereas cable signal channels are carefully controlled to be within 7 dB of each other, off-air channel signals can vary dramatically depending on the antenna type and location. Now, when we get everything installed, we'll have to adjust the amplifier gain to be a compromise between the weakest and the strongest off-air channel signal. Next, I'm going to check the internal distribution. I'm going to start by setting the modulator to channel 65. Then I'm going to set the output signal level to approximately plus 25 dBmV. That's typical of what we calculated would be required from the modulators. And I'm going to plug it into the internal jack here in the master bedroom, one of the furthest locations from the distribution panel. I then use the signal level meter at various outlets to make sure I have a signal level between 0 and plus 10 dBmV, and to check for carrier to noise ratio, hum levels, and record these results as well.
Hey Grayson, how's it going?
Hey, not bad. Hey, I measured all the output levels of all the external jacks, and the difference between the worst case, which is down in the office, and the best case in the guest room, is only 5.5 dB.
Well, that makes sense. The office has probably 100 feet of coax on it additionally.
Yeah, it makes sense.
Yeah, you know, if it was any worse, say around 10 dB, we would add attenuators there to even it out.
Sure, right at the external jacks. That sounds good. Installation of the off-air antennas is next. Now, data from the CES antenna website indicated we definitely need a high-gain antenna at this location. But with all these mountains around here, directivity of the antenna is going to be the most important factor to cut down on the multipass signals we're going to get. Dave, tell us about the antennas we've chosen for this site.
Well, in general, all high and standard definition digital signals are in the UHF band. What we've chosen is a separate optimized UHF bow tie array reflector.
Nice.
This has an excellent front to back ratio. And this particular channel master has approximately a 40 dB front to back ratio.
That's nice. And this baby ought to definitely cut down on reflections from these mountains. Now, earlier Dave and I tested this antenna at various locations on the roof to see what we could expect. Okay, you're going to hit 19?
Okay, 19.
Okay.
Got it. Got -2, -2, -4, -19, +4, +6, +14, +17.
Okay, looks good.
16.8, 17.2.
All right. So Dave, what are we doing for a VHF antenna?
Well, since VHF only antennas are hard to find, we've removed the UHF section off this VHF-UHF log periodic antenna. We've also taken the mount and moved it to a new balancing point here.
Great, so you wind up with a standalone, nice log periodic VHF antenna.
Yeah.
And I see you've mounted the balun at a new connection point.
Yeah, we've had to make a slight modification, but it just took a few minutes.
Great. Now we're going to mount both antennas on the same mast, right?
Yes.
Let's see how that looks.
Sure. While mounting it higher is usually better, we've compromised to minimize the visual impact here. And we're going to take a 5-foot mast, place it into a tripod.
Okay.
On top of this mast, we're going to place a rotator on.
Oh, okay.
And then on top of it, a 9-foot section.
And that 9-foot section is going to hold the UHF on top and the VHF antenna on the bottom.
Yes.
Well, that's not too bad. That's 16 or so feet, but for a house this size, it's not going to look bad at all.
Not at all.
Now, I noticed with these parapet walls, we could have done a side mount to hold the mast, but we chose to do the tripod.
Yeah, I prefer the tripod in this installation. Tripod is a little more sturdy. It can be anchored well to the roof, and we can avoid using guy wires in the installation.
Okay, so that ought to hold our 16-foot without too much difficulty.
Yes.
Here. Yeah. Now, from our site survey, we sort of found that the center of the roof is as good a place as any, so we're going to mount it up here, right?
Yeah, that'll work great.
Now, we talked about using a separate FM antenna. Are we still going to do that?
Yes. We're going to use this FM antenna. Well, most of the FM stations here have great signal strength at 5,000 microvolts. The local NPR station is very weak. So we're going to aim this antenna at that station, and there should be plenty of signal strength left over for the rest.
Sure. Now, you still have the option of using the VHF antenna for FM reception as well.
Yeah, and we'll try that after everything is installed.
See how that works. Okay. We first install the tripod mast mount. Then install and level the first mast section using the tripod securing bolts.
That way, well, that way. So that's pretty good. Yeah, that works.
Our next task is to install the rotator on the mast. The rotator uses a 3-conductor control cable from the control box. We use a 14-4 speaker cable for the job. The rotator simply clamps to the top of the mast. We then attach the UHF antenna to the top of the second mast section and attach a short section of coax to the supplied balun transformer. Dave and I then install the mast into the rotator and temporarily bolt it down. Since the VHF antenna is mounted on the bottom of the mast, we simply walk it in place last. Be extra careful while handling these multi-element antennas to avoid an eye or face injury to yourself or coworkers. We clamp the antenna in place pointed in the same direction as the UHF antenna. Finally, we install the UHF-VHF combiner just below the VHF antenna. Our final task is to install coax cables from each antenna to the combiner. First from the UHF antenna, and then from the VHF antenna. We then attach the feed cable from the distribution center to the combiner output. Now, rotators are rated for a maximum weight in wind load area in square feet. Now, that's the equivalent surface area of the antenna that the wind sees. Now, check with the manufacturer of the antenna you use to determine the wind load surface area to make sure it doesn't exceed the rotator limits. The surface area of multiple antennas adds together. When securing the cables to the mast, make sure you leave enough slack in the coax to allow the antenna to make a complete turn without binding. Now, once we have the rotator controller and television receivers installed, we'll come back and accurately aim the antenna. For each channel, we're going to aim it for minimum multipath interference. When we finish up here, we're going to start the FM antenna and then the satellite dish. Dave installed a grounding block for the off-air and FM antenna to the mast tripod. This will ensure that all antenna metal parts are grounded to the building grounding electrode. We use weather protection boots over each connection and provide service loops in each cable before we secure the cables with UV-resistant tie-downs. To install the FM antenna, we use standoff brackets attached to the parapet walls. These are more than adequate for the short mast and small lightweight antenna. The antenna simply clamps to the top of the mast using the supplied clamp and bolts. Dave attached the coax feed from the grounding block to the antenna balun and secures the cable to the mast. While we're at it, we decide to go ahead and align the antenna.
Keep going.
We use our worst case station and align the antenna for maximum signal level in microvolts.
Good. All right, let's set it from there.
Dave, tell us about our satellite dish installation.
Well, we're going to be installing an elliptical 3 LNB satellite dish so we can pick up all 3 DirecTV satellites.
And this new head has got a 4-output multi-switch built right into it, doesn't it?
That's right. It'll work great in our installation because we're installing 3 satellite receivers into this home.
So we can wire directly right out of here to the receivers.
Yes.
That'll work great. And I assume we're going to install it right here.
Yeah, at this zip code we need an azimuth of 175 degrees and an elevation of 52 degrees. And the dish can be placed anywhere here close to the cables and close to the ground connection.
Now I assume the 52-degree elevation is going to clear this parapet wall without any trouble.
Yes.
Now a 3 LNB dish like this needs an unobstructed view at its azimuth and elevation of at least 18 degrees, so it can easily see all 3 satellites from the 101 to the 119 position.
Again, no problem in this location.
So let's see how this thing goes together. I assume we're going to start with the mast first.
That's correct.
Okay. The first step is to mount the mast into position so that the top of the mast can be made perfectly vertical by movement in only one direction. On our slope roof, this means setting the base aligned with the slope. While Dave does that, I assemble the dish to its mounting bracket. The bracket will adjust the dish tilt and elevation. This particular mast has a handy built-in level to make sure the top is perfectly vertical. We next set the tilt angle on the dish based on a table showing the required tilt for our location. Then we set the preliminary elevation for our location and temporarily tighten it in place. Slip the dish over the mast in the general direction we know it needs to point. Okay. Install the 4 coax cables from the distribution center to the 4 outputs of the built-in multi-switch on the LNB assembly and secure it to the dish. We then set the azimuth by eye to 175 degrees, the approximate angle for Tucson. Now, while you can aim the dish accurately with it connected to a satellite receiver and to a television set, it's a lot easier to do with a good satellite signal level meter such as this. And we've temporarily connected this to one of the receiver outputs on the LNB, and we're going to adjust both elevation and azimuth here for the strongest signal we can get. So let's do our azimuth first. Good. Higher, higher. Going down, go back. Let me check the other LNB here. All right. Let's rock it around that position a little bit. Okay, that's it. Let's lock it. Okay, let's try it. High, high, high. There it is. There it is. There we're good. We're good. Now let me check the other. That's good. That's it. Lock that, baby. We'll test our signal strength and alignment with the receiver later when everything is installed. Bye, guy. Now, these are the outside color cameras we're going to be using. These Gray Fox cameras get their power directly over the coax cable from the camera module in the distribution center. They also have a frequency agile modulator built in that can be set to any UHF or cable channel. Dave, how do you set the channel on those things?
Well, I'll take off the camera lens cover.
Okay.
And then using a screwdriver, I'll pop the camera electronics out of the body. And inside here, there's a dip switch for setting the camera channel.
Oh, okay, easy enough. Now, according to our channel plan, this guy's supposed to be set to channel 57.
Correct.
Okay. All right, I'm going to watch you put it in.
All
I
right.
have no clue how to get it screwed in. Great. Yes. Hi, Dave. It looks like you made quite a lot of progress since I was here last.
Yeah, we have, Grayson.
Ooh, nice racks.
Thanks. These are EAS racks. It's called an AV track. It makes it real nice to put equipment in, can pull it out, you can service it and make the connections easily in the back.
So it just rotates around so you can get at everything.
Yeah, it's great.
Ooh, great. I wish I had a couple of these. So what's in it?
Well, we have a surround sound receiver, a CD player. There will be a DVD player here. Additionally, we are taking some signals and modulating throughout the house. We have a couple VCRs and a satellite receiver here.
Right.
And then in the rack to my right, we're going to have a couple additional satellite receivers and a DVD.
So baseband's coming from over this rack to this one.
Right.
And the rest of the equipment is being modulated by the Channel Plus modulators in this rack.
That's right.
And they're going to go throughout the house. And then we're going to make some fine-tuning adjustments on the satellite dish and the off-air antennas, right?
That's correct.
Yeah, we want to see that too.
Yeah.
I'll catch up with you guys
All
later.
right. Thank you.
As part of the final equipment installation, Dave attaches the cables from the rotator to the rotator controller and powers it up to make sure everything is working. And Jim attaches the baseband cables from the source equipment in the racks to the 4-channel modulators. Each input accepts left and right audio and S video. While they're finishing the entertainment center, I prepare to do a final performance check of the RF distribution system. I attach a broadband RF noise generator to the off-air input without the filter and set the output level to 0 dBmV. I attach the spectrum analyzer at the outlet with the worst case loss, and set the analyzer to display 0 to 950 MHz. The response looks good, starting at 50 MHz up beyond 900 MHz with no dropout or extraneous noise. But notice the gradual 10 dB attenuation or tilt over the passband. This is caused primarily by the 150 plus feet of coax to this location. Now this might be a problem for cable service and require tilt compensator at the input to the distribution amplifier. Next, I perform the same test with the low-pass filter on the input to the distribution amplifier to check for adequate attenuation. As expected, the filter drops the signal by about 25 dB, starting at 600 MHz up through 950 MHz. Meanwhile, back at the entertainment center, Jim programs each 4-channel modulator, starting with off-air channel 59 in the first channel position. We test the modulator signal levels at various locations to make sure the lowest level is well above 0 dBmV and the highest level is below plus 15 dBmV. I use a portable TV to check for good picture quality with no noise or hum. We next test the camera modulator levels for the same range and find the average level is too high by about 5 dB. To fix the problem, Jim installs a 6 dB attenuator between the camera module output and the distribution amplifier input. We also check to make sure each camera is on the right channel and the picture quality is good. Next, we need to program the rotator controller for each station. We first need to synchronize the controller with the actual antenna position. This is done by setting the controller to a known position, in our case 180 degrees, and then aligning the antenna so it points to 180 degrees. Jim uses a compass for a visual alignment, then tightens the mast to the rotator. While monitoring the signal level at the receiver, Dave and I use the antenna web list of the approximate direction of each station as a starting point to set the antenna position. We then fine-tune the direction for the best signal and minimum multipath interference. Okay, let's go to channel 9. We continue working through the list for each station. 4, 1, +2, +3, +4, 5.
See if we can maximize that.
Down, going down. Up, 4.7, 4.8, 5.1, 5.2, 5.3. Once the optimum direction is found, its corresponding channel number is programmed into the controller. Okay. With the off-air station reception optimized, we make a final check of the off-air signal levels and find that the highest level occurs on channel 13 at about +19 dBmV and the lowest usable channel level at about +5 dBmV. Okay, Jim, let's crank this thing down a little bit. We use the test results to reduce the external amplifier gain by about 4 dB. Okay, 8, 7, 6, there you go, 7, 6 right there. Next, Jim uses his considerable tweaking skills and a cell phone connection to me at the TV to fine-tune first the azimuth, then the elevation of the satellite dish, searching for the best compromise between the 3 satellite positions.
$95? All right, that's great. Thank you.
Finally, Jim checks for a good signal level on the FM receiver and programs in each station. With everything aligned, programmed, and tested, the racks can be slid back into their final position. Well, David, it looks like that finishes up the majority of the installation.
Yeah, we're just about there. We have the Alana audio to check out and the security system to finish as well. I want to thank you very much for helping us on the installation.
Hey, no problem. We enjoyed it, and I'm glad we got a chance to put that on tape. Looks like the customer's going to really enjoy this installation.
I think they're going to love it.
Well, that completes the course. As always, we hope this has been an enjoyable and educational program.
Your workbook has a list of where to obtain additional information about the products and test equipment covered in this course. And if you have any questions about any of the material, just drop us an email.
We also suggest you take a look at the sponsor information at the end of the program. It's got additional information on where to obtain the products you saw in the course.
And then be sure to check out the training department's website for additional courses and skill builder videos.
So let's go get something cold to drink. I'm buying.
If you're buying, let me get the door for you.
Okay.
I have a question though, Grayson.
Yes?
When we started this whole thing, didn't you say there were going to be some babes in this video?
Yes. Yes. You believe that?
I heard that.
Keys. The keys. Since the beginning of the structured cabling industry, Gray Fox has been at the forefront, pushing innovation and commitment to quality in the home networking market. The company offers a broad line of highly modular structured cabling systems that support voice, data, video, and audio networks for both large and small projects. They've also innovated a wide range of network support modules for everything from high-speed internet to distributed audio, and a full line of support hardware you'll need for a professional installation. Gray Fox's family of residential network wiring products help ensure that America's homes are ready for the future. For over 20 years, Channel Plus has been acknowledged as the premier brand of multi-room audio and video distribution systems and the preferred choice of professional installers. Channel Plus products allow homeowners to enjoy an advanced integrated home network, providing outstanding picture quality to every television, exceptional stereo performance in every room, clear telephone connections, easy satellite access, and robust home computer networking. Channel Plus products will empower the homeowner with the ability to watch and control their DVD, satellite dish, security cameras, and VCR from every TV in the house. CommScope manufactures a complete line of cable for data communications, computer networks, industrial automation, broadcast, telecom, satellite reception and transmission, residential infrastructure wiring, and security applications. Their Ultra Home residential infrastructure cables provide a single, easily installed cable solution that permits any room in the house to be wired for multiple phone lines, data, multimedia, security, and energy management.